Okay, let's give you guys some more practice. So use the ratio test to determine if this series will converge or if this series will diverge. So press pause and have a go. Okay, so to use the ratio test, we will need to find this value here. So an plus 1 is this, and this thing here is the reciprocal of an. So this whole thing here becomes this. So when you get to this stage here, um, have a quick glance. N is moving from 1 to infinity. So if n is always between 1 to infinity, then um, then this will never be negative. 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 The whole thing here will never be negative. So we can discard the absolute sign. So from here, discard the absolute sign. That will then take you to here. So now I'll multiply this out. So that will then give us this. So now, let's try and now let me think. Now let me think. So we are currently here at the moment. So let's have a look at this here. This thing here. So you've got one block multiplying another block, and here you've got one block multiplying another block. Well, n plus 1 factorial is n plus 1 times n factorial. So you can write this block as this thing here, as this block here, and then rewrite this block as this block here. So now this block will cancel out with this n factorial. This n factorial here will cancel out with this n factorial. So wait there. So we were here earlier. Rewrite this as one block multiplying another block, and then this block here as one block multiplying another block. This will cancel out with this. This will cancel out with this. Okay. So that will then take you to to here. That will then take you to here. So now let's try and understand what's going on here. Okay, so this you can actually simplify with this, but let's try and understand what's going on. So looking at this, 2m plus 2 factorial. Well, when you don't understand this, put something simple into the end, just so that you get an understanding of what's going on. So let's put 3 into this n here. So 3 times 2, this thing here will be 6. 6, and then you have to add 2, so that would be 8. So this thing here factorial would mean 8 times 7, 6 times 5 times 4 times 3 times 2 times 1. 2n, this 2n here, put 3 into here. That will be 6 times 5 times 4 times 3 and so on. Well, remember n is 3, so this is your n here. So 2n would be right here. So 2n would be right here. This is 2n. This is your 2n. And then you can see 2n here these will cancel out. And then what's left will be this term here, which will be 2n plus 1. Which will be 2n plus 1. And this term here will be 2n plus 2. 2n plus 2. So because these 6 have been cancelled out, all that's left is 2n plus 1, 2n plus 2. So the point here is that this thing here, you can simplify with this. Well, rewrite this thing here as 2n plus 2 times 2n plus 1 times 2n factorial. So now these two will cancel each other out, giving you this. So now we are trying to find the limit of this whole thing here. Well, multiply this out. That will then give you this. So as n heads to infinity, towards infinity, the numerator will just act as 4n squared, because this is going to be insignificant. This is going to be insignificant as n heads towards infinity. Well, the denominator, as n heads towards infinity, the denominator will just be n squared, because this is going to be insignificant. So the limit will be 4. Okay, so when you so the limit would be 4. So going back to the beginning of time, we were trying to determine if this will converge or if this will diverge. We would use a ratio test. When it comes to the ratio test, we would need to know this value here. Well, we've just worked out that this value is 4. So if our value here is 4, then 4 is greater than 1. So this is our scenario here. Well, our value here is not less than 1. So this is out. Our value here is not equal to 1. So this whole thing is out. The only thing that matters to us is this thing here. So our value here is actually greater than 1. So it tells us that the original series will diverge. So this series actually diverge just because this number is bigger than 1. Okay.